let's get the show started. Hello, everyone. Thank you all for joining. It's time for another exciting lightning talk. I'm Parag Katkar, your host for tonight. I'm the head of consulting practices at Rhythm, and we have several awesome lightning talks lined up for you in the upcoming weeks. Our lightning talks are hosted every Thursday at 5:15 p.m. Eastern Time. And each week, one of our practice area consultants speaks on the latest and greatest technology trends in the industry that will help you keep learning and growing in your career. So this week, Eric Marcatoma, who is an awesome software engineer, is going to talk about the state management and compare between Redux versus MobX. And as a lot of you know, Redux and MobX are two of the most popular external libraries that address the state management and front-end applications. And I'm really interested in knowing how they stack up against each other in terms of their data structure, their scalability, their data storage, their overall popularity, and most importantly, the learning curve that's needed. So I'm super excited for this talk. So without further ado, let's get it started, Eric.
Thank you so much for that introduction. So thank you guys for coming to my lightning talk. So today we are going to be talking about Redux and MobX and the differences between the state managements. So a little overview of what we're going to be talking about today. We're going to be talking about why do we need state management and what kind of problem it tries to solve. And then we'll just dive into what is Redux, what is MobX, and we'll have a slight comparison between them. And then we'll see which is a better option for your application. And then we can just open the floor up for some questions. So why state management? So in a simple application, there's usually three parts to an application. We have your state, which is usually the source of truth for your application. We have a view, which renders your current state of your application. And then we have actions which can trigger changes to your state. And once those changes are made to your state, your UI or your view will update according to those changes. And in a simple application, we can have data flowing in one direction down to your apps. For example, here we have an app component that probably holds the state, and we can pass down your piece of state down to your header or your task component, which is rather simple. But as your application grows larger, it is rather hard to keep track of where your data is going to, what components needed, and just making sure your app doesn't re-render when it's unnecessary. For example, here on the right side in the image, you can see an application which has 5 layers or 5 levels of components. And if our component all the way at the last level wanted a piece of state from your from the higher component, it would have to get passed down through all these components for it eventually to reach down to your last level components. So one of the reasons state management libraries are important to use in large scale applications. One of the examples here is to avoid this kind of situation where you have to prop drill and pass in information to your components when unnecessary. This can slow down a lot of the development process in any team that you're working with or building an application. It can slow down the process. So with state management, we have a kind of like a structured workflow for everyone to follow. We follow a certain pattern, so it's easier and faster to develop an application. And your data or your state is in a organized data structure, so it's easier to keep track of state changes and update those changes as well. So the solutions, first we'll be talking about what is Redux. So here Redux is one of the most popular state management libraries. It combines Flux and functional programming, and Redux is pure by nature, meaning that all the functions that are used to update our state are pure functions. So in Redux, we have a single store, which is our single source of truth, and our state inside our store is immutable. So our dispatcher, what I mean by immutable is that state is cannot be mutated. In Redux, the reducer will update our state by cloning the current state and creating a new state and using that as its a new source of truth for our application. So here in the diagram on the right, we can see the flow of data and how Redux handles in action. So here in the UI, we can see we have two buttons, the deposit and withdraw. The user will click deposit $10, and this will trigger an action or an event in the application, and our event handler will then dispatch an action, which has a type and a payload. The type will let the reducer know what kind of action we are performing in our store and what needs to be updated. So our reducer will then take in our old state, make a clone of that old state, and in that clone, we will update that specific piece of state, and we will use this new state for our UI to be re-rendered. So that's kind of like the flow of, or the structure of Redux, the pattern that follows. So now we'll talk about what is MobX. So MobX follows a functional reactive programming implementation and prevents inconsistent state by ensuring that all derivations are performed automatically. As you can see here, we have actions, state, derivations, and reactions. Our actions are methods that will mutate our state. Unlike Redux, state is automatically mutated here and they don't make a clone or a copy. We just directly make a change to the state. So our actions are methods that update our state, and our state can store any different types of data types. And from here, we have our derivations, which are basically any computer values that can be derived from the store. For example, if we have an application, a to-dos application, and we are trying to find out the number of to-dos that we have stored in our state, this can be done with a function, and the value of that, the output of that function would be considered a computed value because we are deriving that information from our state. And a reaction would be a side effect in our application. For example, something in an action triggered a state change, and that state change can trigger a network request to our server to grab more data or maybe send something to our server. So this would be considered a side effect. So we have a little diagram here that kind of like displays the data flow of a MobX application. So we will have an event that happens on the UI. For example, someone clicks a button, this will trigger an action, and this action will update our state. And now, once our state is updated, our components will see that our state is updated and will automatically compute a new value, or it will have a reaction, for example, a re-render or a network request. So here I can show you just a little snippet of how simple it is to have a MobX store. Here we have a pet owner store class where we have two pieces of state, pets and owners. We're keeping track of how many pets there are in the store and how many owners. And here we are defining some properties, and we give it a definition of what we want it to be in the store. For example, pets and owners are observables. So MobX is aware that these can change, and we should keep an eye on them, right? And then total owners, total pets, these are computed values because we can calculate or compute how many owners and pets there are in the store. And then here we have our actions, which are methods that will update our store. And then here we have a simple component, a pet list, which will display the number of pets in our store. And we also have some event handlers, like in order to add, create, or update a pet. And as you can see here, we are calling these methods to update our store. And all we simply have to do here is just use this observer wrapper around our component, which will then let MobX know that if any updates of state happen, we will re-render this component, and only this component will re-render when any state happens and no other times. So that's just a quick overview of MobX. So now we are going to jump into a comparison between Redux and MobX. The first thing we'll talk about is the boilerplate code. One of the biggest complaints, I guess, from developers with Redux is it's very boilerplate heavy. A lot of like the capabilities that Redux has to be explicitly coded. So there's a certain pattern you have to follow. We need different types of files to be set up in order to keep track of our state. But at the same time, it does help working with a larger team because now everyone can follow a certain pattern. It's a little bit more strict compared to MobX, where it is implicit by nature. So you need less boilerplate code, but this also allows for an easy setup, just how I demonstrated in the previous slide. You can just set up a simple class and set up your observers, your actions, and your computed values. In terms of scalability, Redux is simpler to scale up, and this is because our reducers are pure functions, which means we can easily keep track of state. We know, given a certain input, we know what the output would be. So it's very predictable. So it's easier to add new features to our application because it is easier to predict what will happen. MobX, on the other hand, due to its impurity, is a little harder to maintain and test code as your application grows. Next, we'll talk about our data structure within Redux. As mentioned before, Redux is just a plain JavaScript object, and this JavaScript object is immutable. Like how I was explaining with the data flow, JavaScript makes a copy of the old state, updates the clone, and then we'll use that new state for our application. And on MobX, state can store any data type, and users don't really have to worry about how to update our state. Everything is kind of done behind the scenes for the developers. Then we talk about debugging in Redux. With Redux has an advantage over MobX in debugging, and this is because of the fact that state is immutable. It's easier to keep track of old state and new state. And also because our reducers are pure functions, we can know what to expect from our functions given a certain input. And also Redux has a large developer community and tools such as Redux Dev Tools. Within Redux Dev Tools, there's a cool feature called time traveling debugger, which kind of like displays all the different states of your application when you are using it. So it's easier to like see where a bug happened or the problem within your application. In MobX, due to the abstraction of code, debugging is a little more difficult. Everything kind of happens behind the scenes, so it's a little harder to see or where the error happened in your application. And on top of that, smaller developer community and not the same quality of tools. Like I said before, a cool thing about Redux is that it has a lot of cool tools, like the time traveling debugger. And all in all, we come down to performance. Redux has a single store, which is easy to track because there's only one store to track. But there's a problem when your application has a lot of or frequent store updates, which can slow down the process a little bit compared to MobX, where the simplicity of creating multiple stores gives MobX the ability to better handle frequent updates to the state. MobX, as you saw, it was pretty simple to set up and create a store for a certain component or review in your application. So now we're to the end where we decide to choose either Redux or MobX. One of the big things between Redux and MobX is also the learning curve. MobX is pretty straightforward when it comes to how to set up your store and your application. You can just create a class and just give your store a definition of what, or your store what to keep track of. You can just tell your store what to keep track of, which piece of state. Compared to Redux, we will have to learn a certain pattern, a workflow, and you would also have to know how each of those pieces in the workflow work. For example, creating your store, your dispatcher, your reducers, and it can get a little overwhelming learning all that. MobX, like I said, is more abstract, so you don't need to really learn as much code. And all in all, it comes down to really preference and application requirements. Like I said, performance-wise, Redux has one single store, but if your application is doing multiple state updates, for example, every minute there's something being updated on your UI, your Redux application will have to keep updating your store or state every single time, the entire store. And if your store is huge, this can slow down your application a lot. Compared to MobX, where we can create a store for smaller pieces of your application, and only that small piece in your application requires that store, and only that piece will re-render when any update happens to your store. So yeah, that's what it really comes down to. And here we can see the little diagram just showing the popularity of Redux and MobX. As you can see, MobX is not a lot of interest, but this is not because MobX is worse or isn't as good as Redux. It's mainly a brand name. Redux has gained popularity over time, and it's still popular. And a lot of people probably don't really know about MobX as much. So yeah. So now the floor is open for any questions.